of our day have suggested that the pyramids were built to be tombs, the eternal resting place of egomaniacal pharaohs, but without so much as a trace of the more practical construction methods. Even a skeptical observer would be forced to entertain the theories of the ancient Egyptians regarding their own creations. Those of ancient Egypt are unambiguous about the reasoning and construction methods of the pyramids. They claim that these structures were more like machines that allowed the king to join with the gods after death. They were essentially stargates to the heavens, where one could be transformed into a god. Instead of masses of men dragging large, perfectly cut stones from quarries miles away, the Egyptians say that magicians effortlessly cut and lifted the stones into place. The pyramid texts, the oldest known religious texts, state that the pyramids were built to throw open the doors of the firmament and make a road so that the deceased king might ascend into the company of the gods. The Egyptians also claim that the pyramids were built by magicians who used quote-unquote words of power to effortlessly levitate huge stones. The Mayan pyramids, although thousands of miles away and built thousands of years later, are said to have been built by the same method and for the same purpose as the pyramids in Egypt. The Mayan people of southern Mexico and Guatemala say that their pyramids were built by beings with magical powers, and that all they had to do was whistle and the heavy rocks would move into place. The Incan people, far south of the Mayans, claim that the massive stones used to build their great structures was carried through the air to the sound of a trumpet. The Mayan traditions state that their pyramids were where men became gods, and the place where gods are made. Curious that these far-flung civilizations would suggest that their pyramids were built the same way and for the same reason. The pyramid, as a symbol of transformation and rebirth, survives to this day. The universe has proven to be quite the onion. Its simple exterior betrays the senses. What science has called truths of the universe is in fact an ever-changing list of theories, each being no more than shades of gray closer to truth than the last. This is not, however, saying that anything but the ultimate truth is useless. Our list of ignorance is great, but our achievements using the half-truths is also great. Our knowledge of an electron, for example, is far from complete, and yet it didn't stop us from harnessing its power and using it as a source of energy and communication. As stated at the beginning of the book, the whole truth requires the mind of God, but it doesn't mean that we can't make application of half-truths. Even this text is nothing more than a long list of half-truths, but, as its author, I'm comforted by the fact that everything else you've ever read is likewise. Even books you believe to be inspired by God are subject to your interpretation, which you could never be 100% sure about and can never prove conclusively. No scientist understands this better than quantum physicists. Unlike the elegant equations of Einstein and Newton, these poor bastards are knee-deep in hideous equations that are so hideous they couldn't possibly describe the universe, and at best only describe what the universe is likely to do, not what it absolutely will do. Quantum mechanics, or quantum physics, is a branch of physics that concerns itself with the smallest particles and spaces in the universe. As it turns out, the subatomic world is not what we expected. Traditionally, extremely small particles like electrons were thought of as tiny billiard balls, bouncing off of each other at mathematically predictable angles. And like billiard balls, their location, direction, and speed could be easily measured. On a subatomic level, particles exhibit strange properties and behaviors. Sometimes, particles would seem to disappear and reappear on the other side of a wall that, mathematically speaking, should have been impossible to penetrate. Other times, particles will seem to dance between the state of being a particle and being a wave. And measuring the subatomic world is also difficult, because in order to measure things like speed, location, and direction, one must build a sensor that interacts with the subatomic particle, thereby changing the course of destiny. Surely these poor scientists are frustrated by particles that always do something different just because they're not watching. It was once a philosophical question as to whether it was possible to break a stone into infinitely small pieces. Scientists and philosophers would speculate over the existence of an elementary particle, a particle that could not be broke apart, and represented the fundamental building blocks of the universe. This continued until evidence emerged that the universe was indeed made of unbreakable, fundamental particles, and these particles were called atoms. It would later be discovered that these particles weren't unbreakable, and were in fact composed of even smaller particles, dubbed subatomic, and included the proton, electron, and neutron. Later still, it was discovered that even these particles were in fact composed of even smaller particles called quarks. That appeared to be where the dividing stopped. Regardless of whether these quarks are indeed the smallest particles, scientists have been forced to conclude that the universe is made out of some kind of elementary particle. But the subatomic world wasn't done violating the rational mind of these poor researchers. As it turns out, even the nature of space and time had its peculiarities. Space and time were thought of as mediums that these elementary particles existed in, and up until the beginning of the 20th century, scientists were spared the grief of having to think of time and space as particles. But eventually came the day when scientists were forced to ponder nearly the same question that had plagued them centuries prior. Can time and space be broken into infinitely small parts? Can I nudge an object an infinitely small distance from where it once was? Can I measure the length of time between two events in infinitely small units? Can I break an inch or minute into as many pieces as I want? Do objects glide through space and time, or do they quote-unquote tick? After much reluctance, scientists were forced to admit that space and time also existed as elementary units, and these extremely small units were called Planck units. A Planck length represents the smallest length of space any object can move. So instead of particles gliding gracefully through space, they instead tick through space. This means that they essentially disappear and reappear one Planck length ahead in the direction that they were moving. What's more is that the particles also move through time likewise, and so disappear and reappear one Planck time in the future. Adding insult to injury, scientists are still unable to gracefully unify the separate forces of nature, gravity, magnetism, and the nuclear forces. These forces, once exclusively thought of as curves in space, are now spoken of in terms of particles as well, gravitons, photons, etc. Einstein envisioned gravity as no more than a warping in the shape of space that large objects create by their presence alone. Like a bowling ball placed at the center of a trampoline, a marble rolling on the surface of the trampoline will appear to be drawn to the bowling ball. Though it appears that the bowling ball has some kind of gravitational hold on the marble is only responding to the curvature of the trampoline fabric created by the bowling ball. As a result, the marble will begin to orbit the bowling ball in the center as a planet orbits a star. Today, quantum physicists speak of gravity as a real particle, a graviton, created by the bowling ball and felt by the marble, slowly drawing the marble closer to the bowling ball. I agree with Einstein's model, as opposed to the graviton model, because of how elegantly it explains changes in the passage of time and the complete lack of quote-unquote gravitational shadows. Even the Bible makes reference to the fabric of space. Countless Bible passages speak of the heavens as a fabric that can be stretched, torn, and folded in on itself. What's been the result of all this quantum confusion? From its beginning, quantum mechanics has been a duct-tape science, constantly patching holes rather than starting from a fundamentally sound model of the universe. Today, the quantum physicist claims that one may not even know the true location, state, and speed of a particle. Consequently, They believe that the universe is loaded with random numbers and therefore, like people, you may only know what the particle is likely to do, not what it will do. That's not science, that's superstition. The universe has proven itself to be mathematically perfect so far, and why would the world of the very small be any different? And where are these random numbers coming from anyway? The gods? A computer programmer knows a computer can't actually produce a random number, but instead can produce a series of numbers that appear random. Ancient man may have mistaken the locations of lightning strikes as being random, but the places lightning chooses to strike was never random, a fact we came to discover after we understood the nature of electricity. Ancient man may have mistaken storms and earthquakes as random, and perhaps angry gods, but the meteorologist and geologist knows better. At the latter part of his life, the greater scientific community considered Einstein washed up and obsolete because he simply refused to accept the idea that the universe is in any way random. Stating emphatically, God doesn't play dice. While the rest of the world accepted the universe's mystical nature, Einstein went to his deathbed trying to reconcile the microscopic and macroscopic worlds. In his heart, he knew that the truth of this apparent randomness was out there, and was probably as elegant as E equals MC squared. Maybe Einstein would have done well by considering more than 4 dimensions in his deathbed equations. Perhaps the missing ingredient between apparent chaos and order is the number of spatial dimensions these quantum physicists are taking into consideration. Perhaps the real question is how many angles are there? For the greater part of the age of science, the number of dimensions was thought to be 4. The first, x, representing width. The second was y, representing height. The third was z, representing depth. And the fourth was t, representing time. Initially, it was thought that every object in the universe experienced time equally, but later it was discovered that time was just another direction of motion, which meant that tomorrow and yesterday are no different than left, right, up, and down. With time being just another direction to move in, and with every object in the universe moving in different speeds and directions, naturally, every object in the universe was experiencing time differently. For example, imagine 2 twins born on the same day. One twin is launched off the planet in a spaceship, and the other twin is kept here on Earth. Let's say that after accelerating for 1 month, the spaceship is moving away from the Earth at 99.9% the speed of light, which is 670 million miles per hour. It then slows down, turns around, and begins to trip back to Earth, eventually accelerating to the same speed. Upon returning to Earth 2 months after leaving, the twin exits the spacecraft to find that everything on the planet has aged 5 years. The twin who stayed on Earth is indeed 5 years older, and to him his brother was in space for 5 years. There's 5 years of new celebrities, 5 years of new geopolitical developments, and 5 years of new inventions and technologies. Not only can the twins debate over how long the trip lasted, 2 months or 5 years, but they can also debate over the total distance traveled. The twin who went on the trip, the stars, actually he never made it to one, will claim to have traveled a distance that is considerably less than the people on Earth said he traveled. The effect, that becomes quite measurable when considering things that are moving at high speeds, is called time dilation. This means that if you were to ask every subatomic particle in the universe how old the universe is, each would produce a slightly different answer, and none are lying. To better understand dimensions, one must only envision the relationship between a boat and a submarine. The boat lives in a 2-dimensional world, and its only choices are north, south, east, and west. South is only the opposite of north, and east is only the opposite of west. So in reality, a boat has only 2 angles of freedom. What's more is that other boats may not share the same space with each other. A submarine, on the other hand, exists in a 3-dimensional world. Like the boat, it can move north